one would find around 650 kilograms of permanent magnets per megawatt of electric power, and this is a lot. And for example, in electric vehicle, we could talk about several kilograms of permanent magnets. Why they are essential? Because they are contributing an essential part in the generator or the traction motor. And for that, of course, if you want to be sustainable, if you want to be economical, we are seeking and striving to develop the materials that have the outstanding properties, which means that we have to use the magnets which are the most powerful in the world. However, these magnets are made out of the materials that are not abundant throughout of the world, and Europe has been aware of that for quite some time. And just by our luck or unluck, the most essential parts that contribute to the green development are based on the materials that are not mined in Europe anymore. And Europe has been dependent of the imports of these materials by 90% for several decades already. That is why the European Commission has put down many of the calls and many of the initiatives how to change this by stating that up to now the recycling rates of these very, very valuable materials is below 1%. It was stated in the first talk by Levin Pal today how the recycling would have to go, but it's still not going the path that we would like to follow, and I will come back to this at the end of my presentation. So next slide, please. I'll just focus here on the technical solution that we provided on our institute. It was a part of the PhD that was funded by the Marie Curie Sklodowska Foundation. The idea here was to try to assess the recycling of the most valuable materials and magnets in a sustainable and economical way. So we would want to surpass the current technologies by offering a new technology that is greener, that it's sustainable, and that it works in a closed loop environment. Up to now, how these materials are recycled, and I have to state here, none of these materials is recycled in Europe. All the materials that gets gathered around Europe, it's mainly shipped either to United States or to Far East in order to be either treated chemically, which means a lot of chemicals is used, a lot of wastewater is generated, and a lot of waste has been disposed. Or they can go through the recycling via, let's say, metallurgical routes, where it's okay when it comes, let's say, to the environment. However, we are losing the properties. So the idea that we came up with was to try to use anodic oxidation. This is that we can etch the material selectively by using the electric current. Next slide, please. Okay, so we came up to this idea, and as this was quite a surpass of the state of the art at that particular moment, we have decided to patent the technology. So we have filed the European patent application already in November in 2018. Now the procedure is in the procedure, in fact. So we are waiting for the final comments. We already discussed the patent search, and obviously it will pass most probably. So the idea behind is that we are using a very, very easy or simple assembly where we are using the permanent magnet as an anode and, let's say, something conductive as a counter electrode. And on the end, by using the electricity, we are able to extract only the very valuable magnetic phase out of the system by keeping its properties retained. And on the cathode, we can deposit the iron. So as I said before, we are not burning the environment with any acid, without any base, and we do it in a closed loop recyclable electrolyte circuit. Next slide, please. So we were not sort of resting when we got these results out. We were thinking of how to compare our technology with the existing technologies. That's why we made a sort of semi-professional energy consumption and sustainability studies. Of course, we are now at the progress of doing the LCA of this process, when we were comparing our method on the right-hand side with the already established method of remelting. And when encompassing all the inputs and outputs of the energy and chemicals and stuff, we have come up to the, let's say, evaluation or the result that our system or our approach or our proposition is as efficient as the already existing approaches by carrying a very valuable advantages, which means that it's energetic and economically viable, and it doesn't pose any threat to the environment. At the moment, we are, with the help of the Technology Transfer Office, trying to, how to say, to seek, not for investors, but we would like to pose the idea to the larger community, not just scientific community. Here we come again to the issues that were stated just before me by Janez Strancer, where is the line between investigating, publishing, and sharing, and where is the line about what you develop that you are able to sell it. So we are now at the process. Of course, we have published all these because you are somehow committed to publish this when you are getting funds from the European Union in the frame of Marie Curie Sklodowska. But for example, even in that case, it's not really firm how to deal with inventions which have economical potentials. Just the final thought. The idea behind is that what I would like to pose in general is that, of course, there are investments into the, let's say, sustainable society. And by chasing the Green Deal goals, we will have to somehow really change our mindset. As per now, we are doing stuff in a little small environments, and the big picture is still missing for the Europe. So I think a lot has to be done in passing this information to policymakers and stuff like that, and in order to try and seek for funds in order to make this idea for Europe feasible. Because now, as Levin said, at the moment, it's not economically feasible. That's why people don't do it. So thank you very much for now.
Okay, thank you for your presentations. Any questions? Now we have question from Gregor Yus.
Okay.
Gregor?
Yeah, my question. What's the technology readiness level of this technology?
Yeah, I put here a note and I said technology readiness level of this kind of approach is around 3 to 4. However, the idea to put forward would be, of course, to get additional funds. We are very, very active when it comes to trying to gather the funds from the European Commission. And there would be channels, for example, in implementing and trying to increase the technology readiness level with regards for the RIA or IA project, where especially Europe is investing in making a pilot lines out of this. However, just one more thought, for that you need to have a company that would be willing to partially invest in your idea. Because in order to make it on a pilot line scale, which means TRL above 5, you would need something like that. And this is where we are striving the most at the moment.
Okay, thank you for the presentation. We will continue with the next one with Anna